Hello, algebra students. Mr. Lawrence here. Unfortunately, I cannot be with you today. I apologize. My son started throwing up on Monday night, about 8 o'clock, 8:30, something like that. And so I have to be with you via video. So here's what's going to happen. The president should be running the video in each class. And you'll need to be pausing it, be paying attention. You'll need to be taking notes as a group. And then once the video is over, then you can go ahead and work on the homework. Hopefully you've already looked it up on your Chromebooks, but I thought of having you work in groups and watch the video in groups, but I didn't think that was going to work so well. So I want you to watch the video as a whole. The president be pausing in each class as much as possible. And then if the substitute says, hey, it's cool, you guys can work in groups. But please make sure that you're working, okay? Because we're starting the next chapter and we've got a lot to do, okay? All right, here we go. So the title is Zero and Negative Exponents. And just to begin with, I would like you to make a prediction for what you think 2 to the 0 power is. You shouldn't have any calculators out. 2 to the negative first power and 2 to the negative second. And just write your prediction down. Okay? Now, I'm not going to tell you what those are yet. I'm pretty sure most of you have them wrong. Okay? Remember, we've talked about you can't think about exponents as multiplication. And that's why you're getting it wrong. You're thinking about it as multiplication, even though you don't realize you're doing it. So we're going to come down here and we're going to fill out this little input-output table. And the president should go ahead and pause the video so that you have time to make this table. X is your input, Y is your output, your independent variable and your dependent variable. And you're going to list 2 to the fourth, 2 to the third, 2 to the second, all the way down to 2 to the negative third. Okay, and we're going to see if we can't figure out what some of these are. So now, those of you that think you're just going to fill out the whole table, you're probably wrong. So just slow down, get the table looking just like mine, and when we're ready, we'll go ahead and unpause the video and start to do this. Okay, so if you're still watching at this point, I'm assuming that everybody in the class has this table down. And we're going to have 2 to the fourth power. Well, that's 2 times 2 times 2 times 2, right? So that should be 16, right? Okay, not 8, because this is not multiplication. It's 4 2's being multiplied, not 2 times 4. Okay, and then 2 cubed, of course, would be 8. 2 to the second is 4, and 2 to the first is 2. Now, before we go and fill out these bottom 4 here, I want to ask you what is happening as we move down the table. Can you see it? Let's see here. It looks to me like we're dividing by 2 each time, doesn't it? There's 1 less 2 being multiplied, so it's like division by 2. Well, if that's the case, then I need to be consistent. And look at that, I found it 3 times. So 3 times in a row, I'm pretty sure that's the pattern. Remember back when we were doing nth term stuff back in the first quarter, and we said, hey, we had to check it 3 times? Well, I checked it 3 times. That's division by 2 each time. So therefore, I must divide by 2, which means that 2 to the 0 power must be 1. Yeah. 2 to the 0 power must be 1. In fact, it is true that, hold on here, let me get it, we're going to want to get this down. I'm going to change the font there so that this can fit, okay? Change the size of the font, that is. So any non-zero number raised to the power 0 equals 1. Yeah, any non-zero power. You don't believe me? Let's get a calculator up here. There we go. And let's do 66 and raise it to the 0 power. And look at that. Boom, 1. Yeah. How about 1,568, and we will raise it to the power of 0. What do you think? 1. Now, tell you what, just take a second. After I say this, pause the video and see if you can guess what 0 to the 0 power is. Okay? Hopefully at least a couple people made guesses. I'm sure you said things like 0 or you're not sure. Okay? 0 to the 0 power is actually undefined. If you go back to look at this table, if this was 0 to the 4th, 0 to the 3rd, 0 to the 2nd, you'd be dividing by 0. And you're not allowed to divide by 0, right? So that's why it's any non-zero number. Oh, and if you don't believe me, go ahead, feel free. We'll punch it in, 0 to the power of 0. And sure enough, we got a domain error, okay? So we're going to quit that error. All right, it is not true. You cannot divide by 0. 0 to the 0 power is undefined. Okay. So what does that mean about 2 to the negative first? Well, the pattern can't suddenly change. I mean, that's the cool thing about algebra. You know, when you've discovered a pattern, it's going to hold true. So I'm going to have to divide by 2 again. And now I'm not going to be a fraction wimp because that's going to make this problem way too hard. I'm going to go ahead and go 2 to the negative first. Must be 1 divided by 2. Better yet, let's call it 1/2. Oh, now check this out. Check this out. This negative exponent stuff is so simple. Look at this. 2 to the first equaled 2. And 2 to the negative first equaled 1/2. What relationship do 2 and 1/2 have to each other? What's that? Yeah, did you say it? They're reciprocals. Yes, they're reciprocals of each other. Let's see if that relationship holds for the negative second. Let's see here. We've got 2 to the second is 4, right? 2 to the negative second. I wonder what that is. Well, if I have to divide by 2, 1/2 divided by 2, yeah, you better believe it is 1/4. It does hold. Look at that. 2 to the negative second is the reciprocal of 2 to the second. Yeah, so a negative exponent, sounds like Mr. Lawrence can say something very important here. Very important. Let's see here. A negative exponent means to take the reciprocal of the base. And looks like I spelled reciprocal wrong. Let's see. There we go. Oop. I'm having a little trouble there. Reciprocal of the base. So 2 to the negative second is the reciprocal of 2 to the second. So therefore 2 to the negative third must be the reciprocal of 2 to the third. Well, if you know 2 to the third is 8, then 2 to the negative third must be the reciprocal of that. Well, what's the reciprocal of 8? Why, it's 1/8. Yeah. So now all of a sudden, this stuff becomes easy. Yeah, if you know it means reciprocal of the base, it's really easy. Well, okay, let's go up here and check our guesses here. 2 to the 0 is 1, to the power 0. 2 to the negative first is 1/2, because 2 to the first is 2 when I take the reciprocal. 2 to the second is 4. 2 to the negative second is the reciprocal of that, 1/4. Have I used that word reciprocal an awful lot in the past couple of minutes? Do you think it's super important? I'd like the president now to pause the video and see if you can figure out 5 to the negative third, or 6 to the negative second, and 3 to the negative fourth. Okay? I'd like you to figure those out. So, let's see here. If you're still watching, I assume you've taken some guesses. All right, here's how I think about it. I need to figure out 5 to the third. Well, I know that's 125. 5 to the negative third is the reciprocal of that answer, which is 1 over 125. 6 to the negative second. Well, if I know that 6 squared is 36, then the reciprocal is 1 over 36. 3 to the negative fourth, well, that's 3 times 3 times 3 times 3, right? And let's see here. 3 times 3 is 9. And 3 times 3 is 9, and 9 times 9 is 81. So 3 to the fourth is 81. 3 to the negative fourth is 1 over 81. Oh, this stuff isn't too hard. Now, what would happen on these? Go ahead and pause the video again and see if you can figure these out. Okay? All right, I'm getting ready here to do my answers, so make sure you've given them a shot. Pardon me. X to the negative 6 would be the reciprocal of x to the 6th. Well, wouldn't that just be 1 over x to the 6th? Look at that. It went to the denominator. It was in the numerator. It went to the denominator. This one here, some of you are going to get wrong because you're going to apply this negative 2 to the 8. But that's incorrect. The negative 2 only applies to the y. So the 8's exponent is a 1. So when I go to do this one, I'm not going to take the reciprocal of 8y to the negative 2nd. I'm only going to take the reciprocal of y to the negative 2nd. So it's going to be like 8 times 1 over y squared. Or better yet, I could put that 8 over 1, and I could multiply and get 8 times 1, and 1 times y squared, which is y squared. Do you see that? That's actually kind of simple. It's so simple, it's brilliant. Let me do another one here really quick. Let's say we had 12 x cubed y to the negative 3rd z to the negative 5th. Okay, when I go to do a problem like this, I'm going to draw a fraction bar, and I'm only going to move the things that have negative exponents. So if I have 12, that's the first part, that's staying in the numerator. X cubed, that's a positive 3, staying in the numerator. Y to the negative 3rd, well, that's going to go to the denominator as y cubed, right? 1 over y cubed. And this z will be 1 over z to the 5th. Yeah, pretty crazy, huh? It's pretty simple. The things with the negative exponents switch their position in the fraction. And you're like, Mr. Lawrence, there was no fraction there. Sure, it was all over 1, right? The whole thing was over 1. So this thing had a negative exponent, and the z had a negative exponent, and so they moved from the numerator to the denominator. Now, some of you are thinking, geez, does that mean if it's in the denominator, it'll move to the numerator? Let's test it out. Let's put 6 x to the negative 5th over y to the negative 3rd z squared. Okay? So, I know that a negative exponent means to use the reciprocal. And so these two terms have negative exponents. They're going to be moving. They are going to be moving. So I'm going to leave 6 in the numerator, right where he is, because his exponent is 1. The z squared is going to stay in the denominator because his exponent is a positive. Now the x to the negative 5th is going to move to the denominator like that. Because remember, x to the negative 5th means the reciprocal of x to the 5th. Well, there's x to the 5th. The reciprocal of that would be 1 over x to the 5th, right? And therefore, these two things are equal. Yeah, that's the way it works. All right, I've got y to the negative 3rd, which is going to move that to the numerator. And some of you are saying, well, why aren't you going like this, Mr. Lawrence? Negative 3, and then writing it as 1 over y to the 3rd. You know, and where the 6 is up here, right? Okay, well, it's kind of complicated, but dividing by a fraction, here's the division, there's a fraction, is the same as multiplying by the reciprocal. And what's the reciprocal of 1 over y cubed? It's y cubed. And so thus I get 6y cubed. All right, let's go back up to the other examples here. Now, when I have something like this, the first thing I like to do is to make that a positive. So I'm going to take the reciprocal of 2/3 and change it to that. That's supposed to be a 3 there. And now I'm going to do 3 cubed, which is 27, and 2 cubed, which is 8. All right, this one here, I'm going to do the reciprocal, 7/4, which changes the exponent to a positive because I took the reciprocal. And then I'm going to square the 7 and get 49. And I'm going to square the 4 and get 16. And there we go. All right. that's it for the video. Okay, so now with the sub's permission, you may work in pairs, possibly a group of 3. I don't want anything else. And you can go ahead and get started on the homework. All right, Mr. Lawrence signing off. Have a good night, everybody.